Well, welcome back, everyone, to your Correlation 1 data center technician training that we have. Let's see who's going to be fastest fingers first with a thumbs up to see that you can see the lesson goals for this particular lecture. George in there, Daniel in there, Stacey, Derek, B, thank you, B, Patrick, Catherine. Well, we're all coming in. Okay, that all sounds very good then. So this week's lecture, we're basically going to be talking about hazardous materials. Now you might think, hold on, I'm in a data center. What hazardous materials could we possibly see there? So we will go through some of those and some potential issues and handling methods in there, okay? So a couple of things we're going to cover. We're going to learn to identify the types of hazardous materials we're going to see, have a look at a couple of the labels, and we're going to discuss something called a material safety data sheet, which may have been truncated slightly now to an SDS, a safety data sheet, but it will depend on which data center you tend to go into and which country you're working in. We're going to have a look at some handling and storing of these hazardous materials because we need to do them properly. And in the long run, we have to dispose of those materials in the end. We're also going to have a look at the grasp of spill prevention and what we do with spills, okay? And other items along those. So let's have a look at the first things that are on there, okay? So the first lesson goal is hazardous materials. Okay, large data centers operate with hazardous materials in their areas. Can anyone think of a hazardous material, and please type this into live chat, that we're likely to see in a data center? Let's have an answer on these on live chat if we can, please. Greg's put in coolant. Daniel, lithium batteries. Yes, they contain lithium. Dylan, batteries. Certainly last week we covered UPSs, so the uninterruptible power supplies. We know they are batteries. They come in several flavors, and we're going to talk about those. Bertrand mentions acid from batteries. Yeah. Catherine, oil, acid. Oxidizers. Would we see oxidizers? Dylan, think of where we might see oxidizers in the systems. Stephen's put in there arc flashes from electrical energy. Yes, we are dealing with a large volume of electricity. Remember, we did that stuff about voltage and amps. Yes, we do deal with a high amount of volts coming into our system, both DC and AC. And we need to basically learn how to deal with those. Those are all considered to be hazardous. Cleaners, Logan's put in there. So cleaning products, yes, bleaches. We use bleaches to clean our products, yes. So we need to be aware of bleaches and other cleaning products. Non-water fire suppressants, certainly something we're going to use in hazards. And yes, you can basically rope those into hazardous materials as well. Remember how they put out fires. Fuel for the generators, yes. So diesel. Diesel is carcinogenic in itself. It's also considered to be a very hazardous material. Remember, when we think about hazardous materials, we're not just talking about stuff that's dangerous to us. We are talking about stuff that's dangerous to the environment as well. So diesel, petrol spills and leaks into the ground are basically considered to be hazardous and therefore will cause some problems. Toxic gases from CM cables if they burn. Yeah, very true. And indeed, to expand on that, are fire suppressant gases. Yes, things such as fire suppressant gases we need to consider. Good. Well, thank you very much on that. Okay, so within large data centers, we do know we use a variety of hazardous materials, if you very, very eloquently added into the live chat there. So these can things be such as the coolant for maintenance, systems and materials that need to be identified and marked accordingly. Okay, there is a whole plethora of regulations stand around this. So Occupational Safety and Health Administration, so OSHA, they love their acronyms nearly as much as we do in IT in this sort of industry. Okay, additionally, they talk about how they need to be stored. Okay, there is the National Fire Protection Agency, NFPA. And of course, in the US, there's the EPA, so the Environmental Protection Agency, to ensure that all these regulations and compliances are basically done. So we said that a classification for a hazardous material is anything that could cause a physical or health hazard. Okay, so it could be an asphyxiant. Asphyxiant is something that will essentially stop you from breathing. Okay, these are normally in a gas format, and definitely our fire suppression systems do cause some problems for asphyxia if you get trapped in one of the rooms where they set the fire suppressant off. Modern fire suppressants tend to be okay, and they tend to allow you to breathe okay. But the old-fashioned fire suppressants tended to whip out all the oxygen in the air, and there's the whole way they basically dealt with those. So we need to be aware of these hazards. Okay, there's combustible dust and things like that. So we do get dust in data centers. Ideally, they need to be extracted, and our HVAC systems should deal with those and remove all those particular contaminants. But there are also other combustible materials that we do use in there. As we said, the diesel for the generators, and we know we are dealing with a high amount of electricity, and electricity in itself can basically cause a lot of heat and therefore can cause some combustion. There is acid that we use in the batteries, certainly in there, and there are other materials that are about. So we kind of break these into a variety of different things. Chemical hazards is one we basically covered a little bit. So batteries can be corrosive. Put my teeth back in. Batteries can be corrosive, and basically means they will burn through things because of the acid that's in there. And coolants used in air conditioning service coolants may contain glycerols, which can be toxic if ingested. Electrical hazards. Okay, we know we talked about the high voltage, the high ampage, and what basically occurs in those areas, and we talked about the electrical systems. We also need to consider things such as the physical hazards, okay, such as noise. If you're in a data center with constant fans running, you walk down one of those cold aisles, yes, there can be a buzz. If you're constantly exposed to that sort of noise levels, then yes, this can cause hearing damage over time. So do we need to wear ear protectors? Are they available to us? We also have things when we talk about physical hazards that are general things such as our servers that we carry around in data centers. Okay, they are not light, they are heavy. If you drop them on your feet, yes, they will hurt. Excuse me. Most data centers will provide you with that sort of equipment. They will provide you with shoes that are appropriate, as in they will normally have a steel toe cap to basically manage the fact that you shouldn't ever drop them on your feet. But if you do accidentally drop them on your feet, you shouldn't lose any toes. Let's go like that. So we need to think about those physical hazards. There are also things such as vibrations. I mean, who's heard of RSI, repetitive strain injury, and carpal tunnel you can get? Well, these can be caused through either repetitive actions or from repetitive vibrations. So if we're in that sort of environment, we need to basically go careful of those things as well. Logan's wrist already clicks. Drop it on your feet. Yes, big servers you do drop on your feet. Servers are light compared to UPS systems. Let's be honest, they're just massive batteries at times. So there are some very heavy physical things around there that you should really be using two people to mount. And there are biological hazards. Okay, environments such that we deal with the airflow, and we are conditioning air with a HVAC system. There were some very, I don't know, what do you call it? Very prevalent issues that were in the initial air conditioning industry. And this was a disease, bacteria, which was a Legionnaire's disease. And Legionnaire's was quite dangerous for a lot of people. Okay, and it was indeed to be fatal. HVAC systems is kind of an improvement on the standard air conditioning. Legionnaire's basically grows in the still water that happens to appear in a lot of air conditioning systems. Grows as a bacteria, then gets kicked around, recirculated into the air, and you breathe it into your lungs. Okay, HVAC allows it to clear that out, and it should, touch wood, basically be looking after all that. But again, this is another hazard that we need to bear aware of. Certainly around our cooling equipment, we can get mold with that bacteria as well. And indeed, in a lot of, it's highlighted very much nowadays in rental properties. And we have black mold issues on walls in rental properties But certainly the UK government has basically told the landlords they need to fix rather than just can leave it. And it's considered to be a health hazard and now falls under one of the statutes. So that's where we kind of break those into at the moment. Okay, so chemical hazard, electrical hazard, physical hazard, and biological hazard. And we'll talk a little bit more about those now. But first, we're going to talk about our labeling guidelines. They call them guidelines. They're not really guidelines. These are must-dos, essentially, aren't they? Okay, you must prioritize safety and regulation compliance in data center facilities. Okay, it's the supervisor who is responsible for these. The guy who owns the data center is ultimately responsible for these things. But in the data center facilities, your supervisor must ensure that there are the correct labels and that they are legible, not removed if defected. Secondary containers. Now, what's a secondary container? Anyone fancy telling me what secondary container is in live chat? I have a few questions we're going to throw in because we've got some time today. Anyone know what a secondary container is? Container for the container. I like the thinking there, Daniel, definitely. Give you a couple more seconds if you don't come up with anything. Oh, there you go. Look at that, Daniel. Any other container? I need Daniel 1 and Daniel 2. Should we do that? Okay, so Daniel Collins nailed it. Any other container into which you transfer the material into. So yeah, sure. So we know we bulk buy because it's cheap. But if we take that original canister, that original canister must be labeled clearly and properly because it comes from the manufacturer. So it'll have all the regular warning signs on it, and we'll go into what those should be. The secondary container is anything I tip that material into. So for example, if I'm topping up battery acid, I may get a bulk buy of battery acid in the container. And if I transfer that into a smaller container, that container as well must be clearly labeled correctly in accordance with what we are tipping into it. Anything for resupply and repair? Yes, Stephen, that's very good. Yeah. Okay, so data center facilities and environmental monitoring protocols must be followed. There is a protocol in there. Okay, the DCIFM, which is your data center facilities and environmental monitoring protocols. So they must be followed. Okay, so here's that definition that we've just gone through. Thank you very much for the great answers in the Slack live chat channel. So primary container is the one that it arrives in. It's the big tub. It's where we bulk buy stuff from. The secondary container, as you say, is anything that we pour that material, be it a liquid, a solid, or a gas, transfer into. That is deemed as the secondary container. Now, this is the labeling process that we basically have, the labeling requirements. So our primary container must contain a chemical identity or product name. So it must tell us what it is. It must have the appropriate hazard warning on it, clearly labeled. And it must have the name and the address of the manufacturer or the responsible party on that. Now, you kind of think secondary container will get a bit more lax about it. We won't worry about it. Not really. We basically need the chemical identifier or product name on that as well. The chemical concentration, because remember, we could be mixing it. We could be taking a pure grade product and essentially down doing it, a bit like we do for our car windscreen washers. Okay, we normally take a 100% concentrate for our windscreen washers, and we dilute that, for example, 1 litre into a 5 litre canister where we've got 1 part of the de-icer, and then we've got 4 parts of water, giving us essentially a 5 litre jug. So when we're in a data center, we need to mention the concentration on that. And then again, we need the hazard warning label, okay, if the chemical is deemed to be hazardous. Has anyone seen the chemical hazard warning labels? Tell you what, why don't I just quickly flash that up? I've got a little picture here. So generally, these are the hazard warning labels that you will be looking at. Okay, so we're going from top left, which is flammable, beautiful fire sign. We have corrosive, which looks like it's going to burn something, as you can see. We have oxidization, explosives, compressed gas, excuse me, harmful irritant, dangerous for the environment, health hazard, and toxic. So those are the main ones that we have. Excuse me. Oh, a little bit of a cough there. My apologies. I normally manage to get to the mute button before I start the cough. Okay. So these are the general ones, and this is according to the Global Harmonized System, so GHS. The reason we use this is the Americans use it as well as the English, as well as a lot of Europe, and it's a standard symbol. And the idea is we shouldn't have to be able to read it, so it should be language independent. We should just be able to look at the picture and understand what they are. Any questions about those particular signs? Before we move on. Okay, that's great. I can't see anyone typing. If I do rush ahead and miss out what you're typing, I will happily pull it back and we'll go back to those things. Do remember to smash as many questions as you can into live chat. Okay, so how do we control this in the data center? Within the data center, you must have a material safety data sheet. Okay, it's sometimes truncated into the safety data sheet, the SDS. Okay, it must provide a comprehensive information about the properties, hazards, and safe handling of chemicals. Okay, and the idea of this is to ensure that you and the environment and everything else is safe. It must be formatted in accordance with what essentially is a global harmonized system of classification, so the GHS. Oh, I love their acronyms. There's so many, it's unbelievable. This is just a snippet, it's an excerpt, you don't need to read it, but you can see in certain sections it talks about first aid, it talks about firefighting this particular item, it talks about accidental release, handling, and other things. And we will have a look at that in some more detail. So there are some general requirements. So all employees, okay, everyone, all employees must have access to the MSDS, okay, and adequate emergency training. Oh, what's adequate? One of those beautiful legal terms that comes up in every business I've ever seen is the term adequate emergency training. Okay, this is where it gets interesting. The term adequate means that you must have attended or must have ticked a box to say that you are capable of handling those particular materials if you're in an environment where you are likely to encounter those materials. So if it's not your job to go anywhere near the diesel generators and you are stuck somewhere else in the data center and you're never to go near those, then you do not need training on those items and handling diesel spills and other diesel items. But if it's your job basically to look after the UPS, as in the battery stuff, yes, then you do need to have adequate training, at least attend a training course or be taught how to manage the acid that is potentially inside those batteries. Now, as I said, the data center site manager is responsible for updating that document, the MSDS. Okay, and he normally will update it or review it once a year, depending on the data center, or when any new chemicals are introduced. So if they basically need to add a different fire extinguisher system, then that MSDS will have to be updated and made available, and everyone should be aware of it before that gets installed and is made active. Not only do we need to know how to handle the stuff that's in our data centers, we must also know what we have. So we will automatically need to do an annual inspection, which basically includes an inventory of all the items, all the hazardous items within that data center. And that's a formal requirement. And we know we can protect ourselves by providing security areas. Just like I said, when you're not allowed to play with the diesel generators, it may be there's a locked fence before you get to the diesel generators. There may be a locked door, normally a locked door, before you get to the UPS and the battery systems. So there is a certain amount of access control that is governed in there. So we must review and implement a certain access control for these items. All documents and related materials must be visible at all times in respect of the area for the infrastructure. It used to be, and probably still is, handed out in a binder. Normally in rooms, there are binders basically that deal with things. If you walk into a UPS room, there will normally be a binder on the wall with that MSDS specifically for the hazards that you're likely to see in that particular room. So that if there is an incident in there, you don't have to totally remember everything. In the calm of the day, you can flick it open and go, yes, okay, the treatment for this particular issue is this particular solution. So a battery acid drains, we normally run it underwater for a certain length of time. So it should be on hand at all time, and it's critical it is there. So we got a nice little discussion question there. Think of some common hazardous chemicals you may encounter in a workplace or at home. Where would you expect to find the safety data sheet for these? What kind of information would be useful to get from those? Think about those. There's kind of a triple question in there, isn't it? Think about those. There's a good example, an SDS station, a safety data sheet station. So think about where you'd find or what chemicals you have at home or at work, where you'd expect to find a safety data sheet, or what kind of information would be useful if you were dealing with those. And we'll put a few things into the live chat for that for me. That'd be good. Stefan's given a good example there. Batteries, an alkaline battery leak. Where would you expect to find safety information about batteries? B says cleaning supply at homes. Google's a good answer. The packaging, yes. If you open packaging on batteries, there's normally safety information on it. B, where do you think you'd find safety information for your cleaning materials? Take it this is things such as your bleach and things like that. On the container, B says, yes. So definitely if you've got a bleach bottle, if you look at the side of your bleach bottle, it's in there. So it's written all on the side. All these details need to basically be taken out and added to our SDS. Container manufacturer's website. I don't know how many of you people drive electric cars nowadays, but what about people that are still driving petrol and diesel cars? We see a very common warning, don't we, when we fill up at petrol stations that talks about the petrol and the diesel being flammable, no smoking, no using your phones, and that sort of thing is basically around there. But if you look in your petrol station, there's an SDS, which is probably inside, and you probably won't see it yourself, but there's an SDS basically inside all those petrol stations that tells them what they need to do with petrol and diesel spills. Benzene. Where did you come across benzene? Reginald basically says benzene. Sorry, I use petrol rather than gas. British for you. Sorry about that. Reginald says in plastic detergents. Oh, that's good. Patrick has seen battery warning labels on electric forklifts. Got to check the safety sheet every time you start it up. Oh, I like that. That's really good. That's in the warehouse in Amazon, I take it. Let's have a show of hands. Have a quick show of hands here. Who's ever deliberately, I said deliberately, who's ever deliberately opened an acid battery, a lead acid battery? These are the traditional car batteries or truck batteries. Show of hands if you've ever opened one. Yeah, Victor's in there. Victor, since it's a home or in a workplace, electronics have their own label indicator not to open due to risk of shock. Opening up the cowling on a UPS. But I didn't open the battery yet. When you've looked inside a Patrick basically says he's opened up the cowling on the UPS. And you know, within a UPS, literally, most of the UPSs you have for small server racks are just big tractor batteries, essentially. That's literally what they are in there. That's why they're so heavy. Yeah, you can pull off the label, can't you? Desktop power PC supply. Victor says desktop power PC supply there. So we do know basically when you pop open a lead acid battery, yes, in there's literally liquid lead unless you happen to have one of the gel ones. It's liquid acid in there. And when it charges, it bubbles. I took one out years and years ago because the battery wasn't working very well. In the old days, you used to be able to lift off the cover for those and you simply top it up with a bit more acid when it wasn't charging properly. And then you watch the bubbles fly again, and you go, "Yeah, that's working." And then you close the lid on it, put it back in your car. So they were good fun in the old days. Now they're very much sealed packs, aren't they? Okay, so that's all very good. Okay, so shuffling on from that, we know we're basically saying we can open things, and we know where labels should be at home, and they basically go into the SDS or the MSDS, depending on which company you're working for, and that's where all the information is contained. So I'm not going to do all the work today, as usual. So we have an activity. So based around the safety data sheet. Okay. If you can all click on this link here, it will open the SDS for that particular topic. Thumbs up if you can manage to open that. Let's start with that, shall we? So there's a link in there. If you can't get it, you've got to let me know as well. Stefan, thank you very much for the thumbs up. You're like, I can only see about 5 people on there, Stefan. It's good job you're at the top. You must be the top because you're in a fancy hotel room. Good, okay. So we're going to open that in, have a look at it, carefully read through each section, and we're going to give you 10, 15 minutes. We'll give you 10 minutes on this, I think. So carefully read through each of those sections, try and absorb what's on there, and then answer the questions below referring to that information. So the questions we're going to ask, read out the top one as an example. It's going to be according to section 2, what are the main hazard classifications for this particular product. Daniel, thank you very much for sticking it into the live chat. There's a link there in live chat. Is anyone having problems getting to that particular handout? Feel free to ask any questions as you go along and go through these items. And there are 10 questions that we're going to be asking. Okay, it's 5:32, so we said about 10 minutes, didn't we? So 5:40, we'll come back and we will basically have a little go through some live chat questions and answers on these. I'll hang around so you can ask any questions. Logan Carson says he's had to go through a few SDSs for one of your MRA benchmarks. Logan, I don't like acronyms. What's an MRA benchmark? Just remind me. Ah, good. Logan went through it for an apprenticeship. Annabelle, you got here a little bit late. That's perfectly okay. No need to apologise to me for that. Are you able to get to the link that Daniel posted? So what we're doing, we are going through that particular document, which is a safety data sheet. And we are answering some of those questions. Yes, sir. Thank you very much. Good. About another 3.5 minutes left, people. And then what we'll do is we will poke a few of these answers back into the live chat and we'll have a discussion around each one. Francisco basically did a course on safety at your site for hazmat materials. That must have been really interesting to do that, and steps for transporting them. What was the weirdest material you were having to transport there, Francisco? Thanks, Daniel. You don't have to answer that, Francisco. We understand your pain. Couple of minutes left, people. Good. How are we all doing? We all kind of got some decent answers. We'll kind of run through these one at a time. We might drop a few volunteers in there to give the answers out, and then we'll kind of go through those. Good. I can see one at least ready. Daniel Collins, I think, is still typing. Oh, Daniel Westmore, number 2. Getting in front of yourself there, Daniel. Well done. We like the answers. Okay, so coming round to time. Everyone ready? Thumbs up if we're all ready to go through these. Ready? Victor's ready. Annabelle ready? Logan? Calvin? Stefan? Bertrand? Patrick? All ready? Get a couple more, we'll start cracking through the answers. Good. Greg, Mohammed, perfect. Okay, so let's start cracking through the answers. So we're going to have a volunteer from the crowd. Who wants to answer question number 1? According to section 2, what are the main hazard classifications for XX regular bleach? Feel free just to smash it into live chat. We'll go with the first one, and then you can just confirm that it is. We'll do fastest fingers on this one. Okay, we've got a couple of answers in there. Good. Okay, eye irritation and burning. Category 1, category 1, category 1 from Victor, Greg, and Yinka. Annabelle's got the complete answer in there. Well done. So the main hazardous classifications in there are skin corrosion, so severe skin burning as a category 1, serious damage, serious eye damage, and eye irritations category 1 as well. Who wants to give me a definition of what category 1 means? Oh, Greg's coming with the lowest level. of danger of kind. Inca says it's a severity level. Yes, it is based on severity levels. And Annabelle has basically quoted from the text, but thank you very much. Category 1 is deemed as the highest level of hazard. You must kind of think, well, bleach, how dangerous is bleach? Yes, they define this particular bleach because its strength as a category 1 bleach, certainly in this particular safety data sheet. Okay, doesn't mean it's just corrosive. It basically means it's the highest level. Victor's correcting himself on the highest level. So it's the highest possible risk associated with this particular type of hazard. So this means this bleach must be pretty strong bleach. It's not likely to be the stuff you have lying around at home. It's going to be incredibly strong. So it's due to cause severe skin burns and eye damage. So if you splash this bleach on you, it's going to hurt, and you need to basically seek immediate medical attention to basically get that burn sorted out. If you get it in your eye, it's going to cause serious eye damage. Different levels of bleach. If you've got a lower level concentration of some bleaches, such as your household materials, yes, they will go down in categories, and you might see category 2, category 3. Good. Okay. Who fancies doing question number 2 then? Based on section 3, what is the chemical formula and percentage by weight of sodium hypochlorite ingredient? I know someone's already posted this. Annabelle's in there. Sodium hypochlorite is represented at 5 to 10% by weight. Victor in there as well. No formula. Okay, sorry, I read that out randomly. That sounded. Bertrand says there is no formula. Yes, there is no formula on that sheet. Good. Any questions about that? It basically gives you the concentration in it, doesn't it? No chemical, but wait, Bertrand, well done. It sounds like you've brought that very. Victor, did you find the formula on the sheet? NaClO sounds good from my chemistry lessons when I was young. No, it's basically online. So really, they needed to have the formula placed on that sheet. Okay, so question number 3 then. Let's move on to that then. So look into section 5. What type of fire extinguisher is useful if this is involved in a fire? Daniel says fire extinguishers are fine to use. Water spray is said to be ineffective. Greg says use existing measures that are appropriate to local circumstances and surroundings. If we pause a minute, why is that really important, what Greg has basically said? Why do we need to consider what Greg has basically listed in there? Chemical regulations for the environment. Maybe you got water you don't want to contaminate. Yes, there's options like that. You don't want to get sued by the EPA for sure. That's something very true. So you want to consider whenever you go into a fire, and you've probably covered this in the fire regulations, whenever you go into a fire location and you are asked to extinguish a fire, you've got to look around at what you've basically got. Okay, I know this one says do not use water. Very sensible. But if I'm somewhere where there's loads of electricity, mate, I don't want to pick up a water fire extinguisher just to put out, a wood fire. So we've always got to think about the environment that we're in before we reach for a fire extinguisher or try to put something out. Okay, so although the SDS will basically apply to this particular chemical, we've got to look at the environment we're in before we attempt to extinguish any fire. So very good. Well done and patiently picking that up, Greg. So it basically says you can use anything, but water is not going to be great on it. Fair enough. Good ear. I hope you're able to catch up. Do you need any help on that? We're just basically going through the SDS regulations, or this example SDS. So we are now moving on to question 4. In section 6, what methods are recommended for containing and cleaning up spills of this product? And remember, there is 2 options here. There is basically 2 things that we're going in there. Victor's good in there. Catherine says absorb and containerize. Prevent further leakage comes from Victor, and absorb. Greg, absorb and containerize. Wash residue down with sanitary, down to sanitary sewer, and contact sanitary treatment facilities. So originally, there's going to be 2 sections. There's always 2 in this section 6. Okay, because remember, the first thing we've got to do is contain any leakage to make sure it doesn't go any further and prevent any further spills. This could be a gas, could be a liquid, okay, could be something like that. So we've basically got to consider that first. That's our priority. And then the cleanup is sort of the aftermath. So the aftermath here basically says absorb and containerize. So wash residue down the sanitary sewer. We all know in petrol stations, or your gas pump stations, as you might call it in the States, you have things like sand readily available to basically stick onto things like your petrol and diesel leaks. That basically absorbs it. We then scoop that up, containerize it, and then we dispose of it. That's a good example. Good. Any questions around that one? Good stuff. Okay, then. So question number 5 from section 8, list 2 engineering controls that can be used to minimize the exposure when handling this product. Daniel's fastest fingers first. I'll give a Daniel Collins, as we got 2 Daniels. I have to keep remembering. Catherine, shower and ventilation systems. Okay, we've got 2, but there are 3, and it's good to see a lot of you getting all 3. Good. Victor basically says shower and eye wash stations. Stefan says eye wash station and shower. Yeah, so you've got the 3. I think you've nailed all 3 in there. So it says the engineering measures. So these are kind of physical measures, aren't they? So shower, eye wash stations, and ventilation systems. So they must all be in a suitable area that you can reach if you are handling this sort of material. This is a good excuse. I don't know how many people have ever come across this before. This is a very good excuse for staff to request showers in buildings. Because if your engineering measures say showers, then the company is obliged to provide a shower. That, of course, then means you can then cycle to work, getting a bit greener. You can have a shower in the morning in the shower and then carry on with your work. It's a good excuse, isn't it? Any questions about that one? I can see Catherine typing, and so is Daniel Westmore. See if they've got something in there. 2000 IQ, yeah. Thank you, Daniel. I see several other people typing. Let's wait for them to come round and then we'll have a look. Are you just prepping for number 6? We'll do question 6 anyway. Let's dive into 6. According to section 8, what specific types of personal protective equipment, our good old PPE, should be used when handling this particular item? You were just prepping, weren't you, Daniel Collins? You got it halfway round, just ready to press the enter key, weren't you? Annabelle in there as well. So we have safety glasses with side shields. Okay, face shields, rubber or neoprene gloves, protective clothing, long sleeve shirts. Annabelle's cracking it in there as well with the eye face safety glasses, skin for rubber, and neoprene respiratory. So respiratory equipment as well is basically recommended. So the respiratory stuff basically comes in there if there is a spill. Daniel's got them all in a notepad. Good, that's where they're supposed to be. Just chuck them all in. Good. Any questions about that on number 6 then? Okay, shuffling on to numbers. I think everyone's prepping it now. Number 7, reference section 11. What potential health hazards are listed from exposure to this product through ingestion or inhalation? Okay, let's see who's in first there. Daniel's again prepped in there. We're going to read Victor's as well. So ingestion may cause burns, I'm not even going to try and pronounce it. Issues to the gastronomic tract and respiratory tract, nausea, vomiting, and diarrhea. Okay, so we know it can cause some problems there. Okay, inhaling in high concentration can cause pulmonary edema. That's basically a build-up of fluids on the lungs. So this is where you breathe too much of it in. It can make some of your areoles in the lungs basically to deteriorate and rupture, and that builds up fluid on the lungs. So essentially you begin to drown, essentially, which is not that pleasant, but it's very treatable. Coughing and congestion. Good, we're going to section 8 then. Sorry, question 8. In section 13, how is this product classified for disposal according to EPA regulations? Pass his fingers first again from Daniel. Daniel Collins there. And you see there's basically a bit of a caveat in there. They've kind of gone disposal in accordance with all applicable federal, state, and local regulations. If I was in a data center and I saw that basically in a data center safety sheet, I would be a little bit upset. That data center doesn't move, so we know which federal state we're in, don't we? We know what our local regulations are. Put the local regulations in there. Okay, because we don't have to go and look those up. Good. Victor's got one in there again. Following state law, do not contaminate. Yeah, and again, your packaging. Any packaging you use, so your secondary container, any secondary container you've used to contain this should not be reused. It needs to be disposed of according with essentially your local federal law or state law or local regulations. Good stuff. Who's got enough prep for number 9 then? So based on the information in section 14, are there any special transportation requirements that apply to this product? Daniel Collins, no restrict. I'm sending a bucket of sweets to you, Daniel. Constantly getting these in there straight away. Thank you. Lisa, thank you very much. No restrictions. Well done. Yes, so there are no restrictions applied to the transport of this product. As long as it's in the right container and it's labeled properly, you can stick it in the back of your car and drive off. Okay, we're going to do number 10 then. We'll quickly whip through 10. Where in the SDS would you find the emergency contact phone numbers and web link from the manufacturer? Good. Daniel's come straight in. Daniel Collins with section 1. Details of the supplier. Patrick is basically telling us the details of the supplier of the safety data sheet is in section 1. Yes. So we need those details just in case there's something slightly awry with what's going on. Okay, so we should be able to contact the manufacturer in case of emergencies, in case something happens on what we term as an edge case, so something outside of what we're normally expecting to happen. We go to an edge case, so we should be able to contact the manufacturer and go, hey buddies, what do we do if this actually occurs with our chemical? Could be that it's mixed with another chemical. Okay, that's not likely to occur on our SDS. It may be that someone's brought some weird products in and has accidentally mixed it. So we should always be able to contact the manufacturer of the product and have a good chat with those. Victor made a classic mistake and totally ignored section 1. That's okay, Victor. We all do it. Like reading a good book. We always miss out the prefix. So let's have a little bit of a reflection on this. I think we're going to pop off for a break in a minute. So after we've had a bit of a reflection, we will have our traditional 15-minute coffee, comfort, apple and banana break, okay? So some reflective questions, and this is really for you in the live chat. What's really your overall impression of the safety data sheet, the SDS? Was it easy to navigate, difficult to navigate? Open comments. Informative, easy to navigate and get information requested? Thank you, Daniel Collins. Stephen, difficult. Why did you find it difficult, Stephen? Long and wordy. Yes. It's a really tricky balance. It's a really tricky balance to get between getting enough of the right information into an SDS compared to getting that information to someone quickly. Okay, so they do break it into sections, which is really nice. Okay, but it is important. And the more you read these, Stephen, the better you'll basically get at interpreting those. Touch wood, you'll never have to reach for an SDS in your career as a data center technician. But it's really important you get to familiarize yourself with those so you can find the relevant stuff straight away. Very important guide for safety. Okay, so that brings us to the next one. Which section of the SDS did you find the most valuable or informative, and explain why? Dylan works in a hazmat fulfillment center, and it is very informative and easy. Yeah, if you use it a lot, you're familiar with it. It's really easy to pick up and use. If it's your first time to it, you're likely to struggle with it. It's like the same with operating systems, hoovers, cars. First time you use it, it's a little bit tricky to get used to. So I do understand what you mean, Stephen. And as Victor basically backs me up there, it says it's easier. So which section of the SDS do you find most valuable? Section 2. So what was in section 2 then, correct? And why was it more useful? Dylan, thank you very much, Dylan. The section instructing what to do in the case of an emergency. Catherine, ecological information saves animals. One for the planet. Thank you very much, Catherine. B says the contact information. Call someone if you need to. Greg says hazard IDs. Let you know which one to look for. Good stuff. I mean, I definitely think potentially the one you're more likely to use is the one that's going to tell you what to do in terms of first aid, isn't it? What to do in case of an incident. Victor says the whole sheet was informative. I can't think of something of no usefulness. Yeah, that's good. It is very informative, isn't it? Okay. So were there any sections you struggled with or found confusing? And see several people are typing, so I'll give you a couple of moments to get those answers in. Patrick says definitely seems there's some incomplete data on some of the sections. I guess it matters not so much trade secrets. Anything you buy into your data center, you need to know exactly what's in it. Acronyms and numbers. Dylan, I can't agree with you more. Why are we putting acronyms into documents like this? I hate acronyms. You may have noticed. It's not my passion. But yes, why are we using acronyms? If someone picks up a sheet, they want to read it really quickly and understand it really quickly. Why put an acronym in it? Victor says the firefighting measures it wasn't clear enough for me. Kind of gave you a use any fire extinguisher you like on it, but try not to use water because it's less effective. It's a bit kind of non-committal, isn't it? Less words for Stephen. Yes, less words would be good. Okay, so before we go to a break, there's yeah, last question there. So which is describe one or two of the most important things you learned from this activity. Let's just pick one. What was the most important thing you learned from this particular activity? Not so much just about the SDS. Don't use water to fight a bleach fire. Oh no, if I'm honest with you, Daniel, I'm not even sure bleach is flammable, is it? So I think it's likely to be that bleach is in the area where there is a fire. Don't breathe or ingest bleach. Thank you, Stephen. Love that. Yes. Don't drink or breathe in bleach. Get a beer instead, Stephen. Yes, Daniel says, Daniel Collins, I think so. I thought it's funny that it listed that the water spray would be ineffective. That's really a comment about the fact I didn't think bleach was flammable. Someone's going to correct me. Patrick says that bleach is category 1. I knew it's hazardous. I didn't know it was that hazardous. It's all about the strength of it, isn't it, Patrick? The domestic bleach you have at home wouldn't be classed as a category 1. I mean, it's still pretty dangerous stuff. You shouldn't really do much with it. But the stronger the concentration that you like to get in industrial areas, potentially, yes, it's going to burn when it comes to contact on skins rather than just making it tingle and washing it off. Here's a question. Does anyone know the answer to this? We're going to ask this question before we have a quick 15-minute break. How long should you wash chemical burns for underwater? As needed. Robert's gone for 15. Catherine's gone 15 to 20. Greg's 2. Atkins 20. Bertrand's 20. Stephen's 15 to 20 seconds. The eye wash? Eye wash probably. It's chemical burn on the skin. Last time I did my first aid course, and if I remember this correctly, a chemical burn on the skin should be washed for 15 minutes, but it may be different in the UK across the US, or depend if you do the Red Cross or St. John's. But it's a lengthy amount of time. You hold your arm under a cold water for 15 minutes, and then realize just how long that is they're asking you to wash it for. And the reason for they do that is to make sure they get all the bleach off it, because it's possible with certain liquids, chemical burns that you might get, is that you could put it under for 5 minutes, take it out, but there'll still be residual chemical basically stuck there because it hasn't been washed off by the water. You take it out and it will restart burning. That's interesting. Danny Westmore says in US McDonald's workers use ketchup as a grease for grease burns. First aid is unique, definitely. Okay, so we're going to drop in for 15 minutes of boogie for a Diet Coke, an apple and a banana, if you fancy. Welcome back, everyone. I hope you had a chance to get a little comfort break in, coffee, apple and banana, or whatever it is you happen to have during these little 15-minute breaks that we have. Let's start with a thumbs up for who can see the waste management slide. What do we do? Fastest fingers first up there. William in there. Teng, George, Calvin, Kadir, B, Annabelle. Oh, look at that. We're all coming back. Perfect. Okay, so without further aplomb then, let's kick into this. So waste management, we kind of talked about what we have. Now we really need to talk about what we do when we dispose of the items. So first thing we need to do is identify what the waste is with its proper waste identifying categories. Now you will notice there's a lot of different organizations that get involved in this particular items. As soon as we start mentioning hazardous materials, yes, the acronyms come out left, right, and center. So hazardous waste identification comes from organizations such as the National Fire Protection Association, so the NFPA. It comes from HMIS, which is the Hazardous Material Identification System. So it ensures the proper marketing is involved in these. So these are standards. And the reason we have standards is so that when you move from data center to data center, yes, it's easy to identify and look after these particular materials. And therefore, if we've identified them, we can handle them and manage them in a particular manner, the same way across the board. Now, we know there's storage protocols that come involved in these things as well. So not only do we need to identify them, we need to store them according to strict guidelines. So we know we're familiar with our material safety data sheets. That's going to tell us how we can look after these items, how we can transport them, and potentially some storage instructions in there. Okay. Tells us how we need to mark the containers and essentially the secondary containers, sub-containers that we basically use for those. So we need to make sure we adhere to those regulations as well. And there's disposal protocol. Of course, once we've used particular products and they come to the end of the life, we then need to follow disposal. Again, we are referring back to our material safety data sheet, okay, for guidelines in terms of how we can get rid of these materials when needed. Okay, we need to make sure that disposal is correct, because if we get it wrong, we get slapped with a massive fine from someone. Now, to wrap that up and to finish that up, we also need to report, okay, under SARA, okay, Title 3 of the Emergency Planning and Community Right to Know Act. So another big long acronym in there for you guys. Any facility handling hazardous material substances must report the inventory on a regular basis to the authorities. And this is normally once a year. You will do an inventory of what you've got. You do the weights and measures of how much diesel you've got in your generators, how many batteries you've got, how much grade 1, category 1 bleach you happen to have in your systems, and your coolants within your air conditioning systems. Okay, and it must basically fall into those regulations. Now, the regulation body then steps in and says, this is what you must and mustn't do with these items. So we have the Environmental Protection Agency, US Environmental Protection Agency. Okay, that enforces the regulations on proper hazardous waste handling. Okay, these guys are going to enforce all those regulations that you should be aware of. There's the NFPA, the National Fire Protection Agency. It's their job to make sure you don't burn down the buildings. and everywhere else around you. Okay, so they develop codes and standards essentially designed to minimize the risk of any damage. Okay, to make sure that you look after things, stuff is stored safely and therefore doesn't burn down your locations. And again, there's some following laws that basically put in there for emergency planning and community rights to know. So this is the EPCRA. So this helps plan for emergencies that you may have. For example, if your data center happens to catch fire, what are the emergency procedures? If there's an explosion because some of your batteries go up in smoke, what do you have to do then? And how you manage that particular incident in terms of notifications of all the relevant people and working with the communities. You must be compliant. As you see, there's a lot of different acronyms get involved, and that's fairly important to keep you out of trouble. So let's have a look at fuel handling. So fuel storage and handling. We know data centers require uninterrupted power supplies, not just the batteries with their lovely acid in there and the other chemicals. There's also the fuel, the DRACs, the diesel generators that basically kick in. Of course, they need a large amount of diesel. So the diesel must be stored properly in relevant tanks that are essentially fit for purpose. Is probably a horrible way to use. So there's two forms of storage tanks. You can have an above ground storage tanks, which is what we're probably all very familiar with, which is an ATS, another acronym thrown in there. So above storage tank, or an underground storage tank, which is UTS, underground storage tanks. We know underground storage tanks, probably the one we're all familiar with is our good old gas stations. All those tanks hold all that diesel and petrol and gas for you guys in America is basically stored underground. Okay, so they can be located either above or below ground. But they need to basically be stored in a safe manner. So they must adhere to a relevant design and construction standard. Okay, they've got to be made of the appropriate material. They must have a secondary containment system. We can't just stick a diesel tank on the side and go, that is okay. There must be a secondary containment. So if there is a leak, that then gets contained and we can clean that leak up. We cannot allow things like our diesel and our petrol simply to leak out into the ecosystem, into the waterworks, or just simply soak into the ground. Some of these are things such as double-walled tanks. Self-sealing tanks are not so common. I think they were used in the Second World War for aeroplanes, weren't they? Most of these are double-walled tanks, so if there is a leak, you can see those, and you should be able to visually inspect any leakage. And we'll normally have something like a leak monitoring and detection system. Now, that detection system could very well be a typical example on a diesel generator. We have an oil pan at the bottom that simply sits underneath and catches all the drips and they fall onto the oil pan. That saves it soaking into the ground. A visual inspection of that oil pan will tell you if that diesel generator is leaking. You can simply clear up the leak, get someone in to fix the leak that's in the diesel generator. Okay, so that is a leak monitoring method. There are other more electronic methods to basically detect if leaks are happening. Okay, but a visual inspection is a pretty decent way to look after some of your diesel tanks. We also need to consider the handling. So before connecting or disconnecting anything, if we're reconnecting diesel generators to systems because they've been taken out because they've been monitored, so we need to look at make sure those lines, those fuel pumps are not faulty. All the locks are basically turned on. You've seen there's a classic example when something like this goes wrong in Formula One, wasn't there? Remember they were rapidly fueling cars in Formula One by sticking that big hose on, locking it, pumping the stuff in. If you get it wrong, well, the fuel goes all over the place and everything just catches fire, doesn't it? Okay, that's classic for Formula One. It's not quite as dramatic as that in a data center, but yes, we need to make sure that those are all done properly and we monitor those things. As I've mentioned, fuel handling, we can have drip pans to absorb things. We can have our sawdust or our sand that basically absorbs it all up and helps soak those spills. They all need to be reported. If you notice a spill or you notice some drips, it all gets reported, it all gets logged, it all gets contained. And that way your data center stays out of trouble. Things such as our portable fuel cans need to be handled carefully. Sensible things, isn't it? Keep them upright, make sure the lid's closed when you're transporting it. These simple things need to happen, and they'll all be in the regulations and probably in your standard operation procedure notes that you have for your data center. There should also, we deal with a lot of electricity, make sure that we have proper bonding and grounding procedures during the fueling operation, because we don't want to cause any rogue sparks, just in a similar way that we don't want anyone walking around with a lit cigarette. Okay, so we don't want anything that's going to cause any particular problems like that. So there's a discussion there. So what kind of spill prevention measures do you think should be in place when storing large quantities of fuel? Feel free to poke something into the live chat for this. Someone beat Daniel, please. Oh, she's there. Well done. Perfect. I like that. A bucket load of sweets coming your direction. So no smoking signs are some of the simple things. Yes, we need to have those particular precautions reminded. Double wall tanks. Yes, Bertrand, it sounds like you've run into these before. Definitely double wall tanks. Extra containers. Yes, if you need to drain a container because it's got a leak, well, you've got to put that fuel somewhere else. You can't just go, well, what are we going to do with it? So you need to have a capability to drain a tank if you need to replace it or do some repairs on it. Storm drain covers, secondary containment. Look at that. Fredo, it sounds like you worked in one of these before. Storm drain covers, secondary containments, regular inspections, and overfill prevention measures. Yes, we need overfill prevention measures. Monoxide detectors, certainly from Stephen. Yes, if we are running a diesel generator in a confined area, we need to make sure that we are not going to gas anyone who walks into that particular confined area. Okay, that's good. Thank you very much for that input in the live chat. Very good. So batteries. So we talked about fuel. The other thing that we have has a lot of hazardous materials in is batteries. Okay, we know they can be faulty if they get dented by anything. Yes, we know simply, you know, the lead acid batteries do contain a bucket load of acid. So we have to be concerned about those. Here's a good example of a burn that basically occurs. If it drips out and leaks out, yes, it will create burns. So if we're beginning to transport these things, if there is a damaged battery, they need to go into a specialized container that basically will contain that acid and not let it leak out the bottom. So bear in mind, when you break a UPS battery, make sure that you basically put it into a relevant box to look after it. Now you notice that they use the nickel cadmium batteries in there and the lithium ion ones, wet cells and dry cell sealed acid batteries. So you want to have slightly different things. Certainly the lead acid one just leaks acid all over the place. If you look at a NiCad battery, which is your standard laptop battery or your phone battery, if you flex one of those, now don't do it at home. Please do not do this. I'm just telling you what happens if you do. If you take one out of your phone and you flex it about a bit, it will begin to heat up massively. Okay, so there is a case where you get a lot of heat. You then need to put that into a heat-proof container rather than just leaving it outside because it will catch fire. And you've all seen images on YouTube and things like that of batteries going wrong that are on these cheap scooters that people have purchased, where they've happily caused house fires, where it's been on charge. So we need to be aware of those things. So that's talking about containing and putting it into a fireproof container to do those sort of things. This example here is a battery containing sulfuric acid. Okay, you can see how damaged it is. This one I think is a gel battery, which is why it's not leaking all over the place. But those white crystals that look like white crystals, essentially the gel that's in there. Okay, and that would be acetic gel, a corrosive gel. In this case, sulfuric acid. Again, that needs to go into a proofed container and then disposed of appropriately and according to our beautiful manuals. Batteries, probably in the US, just the same as in the UK and probably across Europe, batteries cannot just be chucked into general waste or recycled. Okay, they've got to be given to a specialized certified battery recycler. Can't sneak these batteries out anymore and just dump them. They've got to basically go to a certified battery recycler with the capability to safely recycle all types of batteries. Oh, look at the fun there. Daniel Westmore, thank you very much for showing that image. That's what happens when a battery gets punctured. So here's a quick discussion question, other than sticking it with a knife. What precautions should we take when we handle batteries like those from a car or electronic device? How should we dispose of those? What strategy should a data center take? Usually, Daniel basically says usually is a bag and a metal container. Yep, something simple like that. I know when I was at IMART, where you had the main data center down in Maidenhead, they have rooms, the UPS system basically have rooms and rooms full of batteries lined on the walls. They're about eight high, stacked literally on shelves, etc., etc. Every couple of years, they will literally replace all those batteries, and they will get a company that comes in and specially manages it, and they carry them in and out, and they basically shuffle it all out, and they are essentially a disposal company for those batteries. They'll take them away, they'll recycle them, and do something sensible with those, getting the materials out and doing something nice stuff. So we do basically need to consider all those items. Good. Water management. Robert basically says the data center would need to set up a contract with a waste coordinator. Yes, it's as simple as that. You need to basically have those items sorted out. Disposable ones I throw away. Reusable ones I toss them in the recycle. I think they're supposed to be disposed of. I know we are in the UK. I don't know what it's so much like in the US. We have a battery collection point at all our supermarkets. You walk into any one of our supermarkets, you go past the checkouts. There's a big bucket where you throw your AA, your AAA batteries, and your C size, D size batteries when they're done, and you simply put them in there. And there is at our waste recycling points as well. Okay, so water. We need to consider what we do with water. Water is one of those precious commodities. We can't just flush it. If we've basically contaminated that water, we need to do something. Okay, we need to consider where we are sourcing our water from as well, because it's not an endless thing. So when you're basically dealing with water management and conservation, you've got to collaborate with your local municipal services for the supply of both drinking water and water you're potentially going to use in your HVAC air conditioning systems, haven't you? And we've got to consider what we do in terms of that excess water that we no longer want to use. Do we simply flush it? Can we flush it according to federal law? There are regulations about the disposal of any water that's directly associated with a data center. So any water that comes into your data center, there's a regulation that tells you how that stuff needs to be got rid of. Okay, there are stringent water treatment protocols, okay, to basically prevent us from contaminating any groundwater supplies, and these regulations must be followed. Ideally, we want to basically try and recycle as much water as possible. And it's quite common for you to actually find recycling water centers. There's a recycling image of a recycling water plant. They can have a big cost impact because it's probably quite expensive to recycle it. But again, you're not getting the new water in, so you're not paying for that. You're not disposing of the water, so you're not paying for water disposal. So it's one of those swings and roundabouts ones. Sometimes you can do it cheaper, depending on the suppliers. Sometimes it costs a little bit more, but you feel a bit better about yourselves because you're simply recycling and maximizing your use of that water. Any questions about the water management end of things? We're still fascinated watching that battery go up, aren't we? I worked for a company that had a lot of apples, and apples are really good, but they had some fantastic batteries running some of the apples. And I remember someone brought me a MacBook Air. A MacBook Air. MacBook Airs, they're fairly skinny, fairly slim, normally like that. This one he brought me literally had bulged up to at least double the size. The keyboard was like that instead of being flat. They brought it out to me and said, Dave, is there something wrong with this laptop? So I kind of went, yes, took it straight away, put it in a fireproof bag, and then organised to get it disposed of. Because I didn't want, things to burn down to me. See Robert typing there. Is it coming through as a question, Robert? Yeah, you need to be careful when throwing into a single stream recycling. Yes, do, because there's a lot of fires at recycling centres. Now, your data centre, luckily, if you're in a data centre, they've got to adhere with the regulations. So, along water, we also have to look after the air around us. Okay, so there is air emissions. There's the Clean Air Act, the CAA, okay, which is a comprehensive federal laws in the United States with a primary objective of making sure that we don't chuck loads of pollutant into the air, basically causing problems for public health and the environment. Okay, the law will basically grant the Environmental Protection Agency authority to establish a national air quality standard. Okay, and the basic aim of these things is twofold. Okay, it establishes a particular environmental rules and it protects the health of the public and the welfare, and it allows them to regulate emissions. The Meteorological Office in the UK, had a whole department dedicated to air pollution. So they used to look after air pollution, dealing with the winds and where the wind's blowing. They would then basically let people know what they could and couldn't burn according to the wind and the atmospheric pressure, to let them know where it would be dispersed and if it was dispersed safely or across populations. So we know data centers are regulated within the normal means of most large companies, okay? And they mustn't emit any pollutants if they can. And this is what our HVAC system does. The idea of HVAC is it simply strips the air, cleans it all out, and makes sure that the only stuff we're pumping out is stuff that we shouldn't, stuff that we should blow out. I mean, you will notice as well, if you have here's a good example. If you have a fire in a data center, the normal fire suppressant system, the way that fire suppressants work, is they pump a whole load of inert gas into that room really quickly. So they have vents that then means the air basically goes out. But there are regulations in terms of what you do with that inert gas that you then pumped into the center once the risk of fire has gone. And as soon as you set off one of those, you've got to make a notification to the relevant authorities to let them know that you have released this gas. And they'll come round and they'll probably go, yeah, it's all right, it's fine. But that conversation must be had. We do also need to bear in mind the number of generators that we are potentially running. Okay, so generators we know burn our good old-fashioned fossil fuel, our diesels. Okay, so we do need to keep a log of how many times we run them, how long they are run for. Okay, and that needs to be submitted every 12 months to the relevant authority. And as I said, we also need to be aware of the ozone depleting stuff, so the ODSs, in some coolant and fire suppression systems, such as the halon or the FM200 gases. Any questions about what we do with the air emissions? Normally quite simple. It's basically just keep a tab of how long you run your diesel generators and what you emit. Good stuff. And then, of course, there are our beautiful miscellaneous chemicals that sit in there. Chemicals that are used to treat the chilled water. Chemicals used for fire suppressants, we kind of covered. Fireproof putty and things like that need to be disposed of properly. Cleaning solutions, solvent lamps, fluorescent lamps, water batteries. No, we don't use fluorescent lamps anymore, do we? We're all LEDs, surely. Anyone using a fluorescent lamp is probably about 20 years ago. That's probably not true, is it? Most data centers and modern systems are basically using LEDs. Any questions about the miscellaneous chemicals? And anything around essentially that handling of the data storage. Sorry, not the data storage, handling of the waste management. Cool. Well, there's a couple of questions in here. Section review. Which of the following is the most important factor when managing and disposing of hazardous wastes? Lots of people are basically ticking B in there. Well done, everybody. C, Kadir, not quite. B. Okay, following specific disposal guidelines is basically in there. Guidelines provided by the MSDS. Robert, MSDS, definitely. Which of the following is primary objective of the Clean Air Act administered by the EPA? See a few of you typing there. Let's see which one we get into this. D, B, D, B, D. No? So give you a couple more seconds. Well, a lot of you's put it in A. So I'm going to click. Should we click A? Not right, is it? Okay, setting. This is a company there. These guys basically set the national ambient air quality standards. That's their job. Bertrand was literally shouting at me, D. Well done, Bertrand. Top work. Yeah, so the last section we move on today is things like spill preventions and responses. So it should be quite a quick session. So, if you're lucky, you might get 10 minutes off for good behavior today. Right, so spills should never happen. They do happen. We know they are going to happen. A lot of it is how we respond to the spills and how we basically try to mitigate the effect that any spill will basically have. Okay, a heavy spill will normally result in an emergency response procedure. And essentially through proper training and planning, we should be able to mitigate these without too many problems. There's our friendly guy in a hazmat suit and a breathing mask with proper gloves on, dealing with some toxins. So we know, again, we've got these particular chemicals that are going to burn through things. We've got our coolants, our cleaners, our battery acids. Okay, they're used throughout the data center. Spills and substances are going to create safety risks as well as potential environmental risks. So spill prevention is first. Prevent it, prevent it, prevent it. Okay, so the first priority is prevent spills. Now we know we can use appropriate containers. Keep the lid on when we're transporting things. Simple things like that. For transferring equipment designed for those particular materials. Only put it in the relevant container that it's supposed to go in and make sure that container is labeled. So they should be sealed and free of leaks. Implement secondary containment like spill pallets under storage areas. We talked about that. You will see if you have certainly if you have a diesel tank on site, a lot of the diesel tanks will quite often be double skinned. But then underneath the double skin, there will normally be a hard concrete pour that's in there. And that idea of that is if they both basically fail, the diesel will drip onto the hard concrete floor, which you should be able to easily inspect. That's why they're raised and not ever basically drop straight onto a flat concrete slab. And we cover a lot of this, and we look after ourselves with this with regular inspections. Whenever you do an inspection of a diesel generator or a diesel containment, you'll basically have to tick a box. You'll have to basically go through, you'll have to log that date, time, who was it, who witnessed it, was it someone else came with you as well? And that basically gets logged in. And that way you can go back, in years to come, and you can simply say, no, this is what we were doing. And this is how we were protecting ourselves. Promptly clean up any spillage. Minor leaks and drips, yes, we can manage and we can cope with. Okay, they need to be reported and noted because a minor one will potentially become bigger and bigger. It's like the good old man with his thumb in the dike. Okay, if you didn't put his thumb in the dike, that little drip would get bigger and bigger and bigger until the whole dike was washed away. So we do need to act and note any particular issues that we do see. There's a good fashion one there. Never leave containers open when not in use. Who's done painting and decorating at home before? I know I do a fair bit of painting and decorating. I've just painted and decorated my dad's house. One of the first things my dad always taught me was when you basically use a paint pot, you take the lid off, you pour it into your paint palette, and you seal the lid again. I was going, why am I sealing that? I'm going to have to take it off in 10 minutes time. So no, because if you knock it over, you lose the whole lot. Everything goes over the carpet. Cleaning paint over carpet's a nightmare. Same thing for data centers, okay? Never leave a container open when you're not using it. Anyone else experienced paint in the carpet before? Have a show of hands in live chat if you've basically spilt paint on the carpet before. Catherine's horrible, isn't it? I did a bit of a summer job once for a guy who was a painter and decorator, and he wouldn't even open a paint pot inside a house. Gabrielle's done it on a blanket. Yeah. Yeah, I mean, it's quite common, isn't it? You spill it and you go, oh, it's a nightmare. Much easier simply to close the lid and then reopen it. I spilled soup. No lid to your soup, is there, Bertrand? In the car. God, oh, spill paint in the car, it's a nightmare. I've seen a couple of pictures, a couple of YouTube videos of people who basically put paint in the back of their car, in the containers, driven off, gone around a couple of corners, paint pots popped open, white or green paint or whatever it is all over the back of the car. Robert, tearful, isn't it? Okay, so the second one is our spill response. So we need to basically make sure that if we do have a spill, we are able to respond to this particular spill. So there's always going to be protocols in place for safe and compliant responses. These protocols will be available to you within the data center. They're not likely to be one of the SDS books you basically rip out, but they are basically going to be about for safe and effective responses. You will be able to read those. They are mandatory that you can access those. Some of the compliances in there for spills are things such as evacuate immediately if necessary. Not those beautiful caveats, if necessary. The general evacuation sometimes does happen. Identify the spilled material and refer to the SDS sheets. Now we know they are easy to read, aren't we? But we should be able to identify those materials because we've had the relevant, sufficient training to identify the material that is on the floor that is spilt. And then we can basically refer to the SDS and say, this is what we need to do with that particular spill. First thing you want to do is protect yourself and everyone else. So PPE goes on, gloves, goggles, etc. If you're not already evacuated, that is. And we can deploy our spill containment and absorption material from spill kits. Okay, we've seen these. These can be things such as buckets of sand, can't they? So they can be crude as buckets of sand. Sometimes they can be spray cans and things like that we would use. Spray cans full of foam or something like that, especially designed to absorb diesel or prevent diesel from catching fire. So it's these types of items that we will have been trained on when we basically come to these particular events. Touch wood, you'll never have to use them. And then we all know we need to get the right safety container to basically put it in. So once we've contained the spill, we then put it into the relevant safety container, which we then basically label and mark and dispose of properly. When it's just decontaminating the area once the spill's been removed, yeah, it's kind of a cleanup, isn't it? Making sure we get rid of everything. You'll notice that little caveat at the bottom there. Only employees who have received spill response training should attempt to handle spills. If it's not your job and you haven't been trained for it, then don't do it. Okay, if you don't have the training, you are putting yourself at risk by basically going into these areas that potentially have hazardous materials. There's a good answer in there. For large, uncontrolled spills, immediately implement evacuation procedures and notify the emergency. So basically, if you have something big goes on, yeah, get out of the place. Okay, any questions about that section for spill response? I mean, spill response is something we all hope we will never have to deal with. Small spills, yeah, sure. Drips and leaks out of your diesel generators, common practice. You will have to note those. You'll have to get someone to deal with those if it's not yourself. But you will be trained to deal with those items. So every data center will have what's known as an SPCC, more acronyms, a spill prevention control and countermeasure plan. They will have these particular plans which will cope with all of their hazardous materials. And we know what's in the hazardous materials because we do an inventory. Okay, and this allows them to basically be active when they are controlling these spills. Potentially you will have routine spill drills, just like you have a routine fire test, where you basically have to evacuate the building. Yes, we will basically be going through routine spill test drills, essentially within sites. These are items in here that we've basically gone through before, aren't they? So prevention methods we've had, use the appropriate containment, routine inspections, designate person responsible for inspections and security. Control procedures. Control procedures is basically deals with our protocol. We have a protocol to quickly shut off the source of containing a spill. So for example, if you have a diesel generator that is leaking, that person will know how to shut that diesel generator off, shut the pipes going to it. That will then prevent any further spilling. And we need to make sure that we have an adequate supply of spill containment and spill response equipment. There are so many. Victor says this means SPCCP is something else, meaning one or more acronyms. I apologize. We are in a world, unfortunately, that deals with acronyms, and it's not just IT and data centers, but everything does it. I mean, I worked for NATS, and they literally had a website dedicated to acronyms. And you look up an acronym, and there'd be about 4 different answers to that acronym, you know, and you kind of go, well, which one is it you're talking about in the reference document? You kind of go, don't use acronyms. It's much easier. Yes, absolutely crazy how many acronyms they have combined in there. Okay, so where do we get to? So that was the control process. Yeah, Amazon. Robert basically is put in there, Robert McDowell. There's an Amazon internal wiki for the acronyms. So you see where we get into. That's why I hate acronyms. Sorry, guys. So once we basically controlled it, we have our control procedure. We then basically need to use countermeasures. So drainage controls to prevent discharge from oil into the water courses. So we can shut drainage off. We can remove the spilled oil. We can use containment measures in there. And then we can look at mopping it up and disposing it. So training and exercises are important. Yes, you must all be trained basically to deal with the environments, the hazardous materials in the environment that you're worked in. And indeed, when I worked at IMART as a data center trainer, we literally went through knock level 1, knock level 2, knock level 3, and what they are expected to do. And we would simply have tick boxes. Has that person received the training for this particular item? Should they be receiving the training? And then we'd simply tick through those boxes, and every employee would have a big list of what they're capable of dealing with, and they wouldn't be going into an area where they are not trained. It would be as simple as that. The data shift manager could not put someone who's not trained on the diesel spillage to look at the diesel engines. Okay, it wouldn't be happening. So that's the training and prevention practices. Okay, we know that key individuals will receive comprehensive skill training because there's just a basic handling, then there's the upper handling, which means they can deal with the incidents and major incidents. And we need periodic drills. There's no point just ticking the box saying you're trained. You need to have periodic drills to remind you of those. Now, periodic is one of those beautiful things, isn't it? Every 6 months or a year is pretty common. If you fail to do the periodic training, then essentially you drop off being certified for dealing with those items. So your SPCC plan details facility diagrams, description of potential spill sources, predicts the flow direction. So you will have a plan that basically comes up and you can read and will detail procedures, contact information, and requirement records. I recommend that your SPCC plan, and this isn't true for all data centers, I recommend your SPCC plan basically lives in what I call a grab bag. We have grab bags at IMART that basically sat by the exit door. And it literally was a bag. Well, sometimes it was a bag, sometimes it was just a folder. That literally, as you walk out the door, because you've had to evacuate the place, you grab that, and that contains your SPCC, and it contains all the contact details and everything you need to know that you can't get hold of in the data center anymore because you cannot get access back into your data center. Term grab bag comes from my sailing days. Sorry about that. That was the bag you basically took off the boat as the boat was sinking. And you stepped into the life raft with what was known as a grab bag. In that grab bag, you had everything you needed and loads of stuff you didn't even know you would need. So you had your water salinizer, you had your purification tablets, you had your fishing lines, you had your sewing kit in case you managed to get an injury and you had to sew yourself up. All that sort of thing was literally in there. 10 litres of water each. That's your grab bag. You step into the life raft carrying that because that is everything you need to know. Because you can't get back into the boat once it's gone down. Good. Okay. So any questions about your response plans? So that's your spill prevention, your beautiful acronym. Yes, your spill prevention and response kit. Good, okay. And then to top that, that's our dealing with spills. Then we have an emergency response plan. Okay, we've not just spilt something, we've blown up one of our diesel generators. All of a sudden it goes from just being a mild spill to being an emergency response plan. So while we basically take precautions, to minimize the risk, there is potential that we will have an emergency. We might well experience a fire. There might well be some other issues in there. We may have all the acid leaking out of our batteries because someone unfortunately has hit it with a forklift truck. Okay, so we can have an emergency response plan. So the ERP, emergency response plan, will have an evacuation procedure, yes, which we drill and we go through. And we do this in all the buildings, don't we? As a data center representative, you must be familiar with that emergency response plan. Okay, certainly with the evacuation procedures. Because sometimes, as you're in your life as a NOC technician, as a data center technician, you might be taking around a few guests. You might be taking around someone who has got their servers and their items living in your data center. So you need to basically be able to take their hand and lead them out following the evacuation procedures. So familiarize yourself with those. Spill response. Okay, spills for hazardous materials like batteries, coolants, and cleaning. Yeah, chemicals, it's important to follow the spill response procedure. There is a procedure, it's documented. We've already said that before, haven't we? And again, only employees with the right training should be doing this. We know full well as well with fire safety, with all the electrical equipment, okay, there is potential of ignition sources occurring within data centers. We do try to minimize it. And there are fire safety plans outlined that basically precede the alarms, notification of the fire department, and use of firefighting equipment. If you get a chance, go on a firefighting training course. They are so much fun. I know it's not just because I'm a pyromaniac at all, but playing with fire and putting fire out is quite empowering. And using those different types of fire extinguishers, you've got to set off each one at least once just to have the fun of them. Okay, because when you do it, you don't want to be shocked when you're basically setting them off. They are great fun to do. Try and get yourself onto one of those courses. Okay, so that basically covers an emergency response plan. Any questions for people on the emergency response plan? See Victor type in there. As I said, most of the time, we will not get to an emergency response plan stage. We should always be able to prevent it before we get to that stage. But yeah, there's obviously been fires in data centers before for a variety of reasons. Thank you, Victor. No questions. Good stuff. So with all this stuff that we're talking about, yes, we are dealing with hazardous materials. Okay, there's a variety of roles and responsibilities that people need to take in the data center. Okay, we must coordinate with the local authorities, and there must be plans to coordinate with the local authorities. So there's roles and responsibilities for the police, fire, EMS, emergency medical systems, isn't it? Emergency medical supplies. I can't remember what they're called in the States. Yeah. All have specific roles to play when responding to incidents. Okay, police obviously do the securing, fire department does the fire suppression and putting out things, and of course providing, you know, rescue capabilities for little Johnny who happened to be stuck on the 3rd floor when the 2nd floor caught fire. Okay, so running up our ladders or letting him jump out onto one of those massive, great big balloons. I've always wanted to do one of those. Don't think they'd let me do that though. And again, our EMS basically look after the triage and treatment for injured people. There's got to be a data center person that is authorized and responsible for initiating the emergency response and coordinating it. It's not like anyone can simply phone up and go, we've got a big fire in our data center. No, it goes through a chain of command. The guy that's supposed to be in charge of that system then pulls the trigger and simply goes, yes, we've got a fire. Fire department's on the way. Police, EMS have been notified. Okay, and with that single point of contact, or that group, could be 2 people normally, but a single point of contact, we then don't get any confusions. We have a head count on the way out of the building, so we know who is still in the building. And the fire department knows who to speak to. So there's not a rumour mill. Fire department doesn't come up and go, who's in the building? And 8 people say, well, I think John's still in there. No, he's over there. Peter's not in. I'm here. It's okay. So there's one person they go to, and that person holds their hand up and says, speak to me. I know everything. And everything should go through that person. And that makes life so much easier. And that person will also have things such as your facility information and access to allow the authorities to respond quickly and effectively. So it must know the data center shape, the data center model. Okay, what rooms are where and the layout in case it gets big time and they have to try and go in and rescue someone. That fire department's going to massively appreciate you getting out that grab bag, a floor plan of the entire building. I'm not sure the fire department cares about access codes. They tend to have one of those big red knockers for that, don't they? And just use that or a fire axe to get into doors. But yes, if you've got access codes and things like that, then yes, systems like that they would love to see. And of course, because they are entering an area that potentially has hazardous materials, they will want to see your safety data sheets on all your hazardous materials that are on site. Now, there's a very important statement at the bottom there that says this information is regularly reviewed and updated. Yes, it's no point having one that's 2 years out of date and going to the fireman, oh, I'm not sure this is it. Didn't we put a wall there? Oh, didn't we move the batteries to that particular location? Regularly updated. It's got to be the right information you give to these people. I know it's a pain because you're never going to use it, potentially never going to use it. But when you do use it, it's the thing that saves lives and gets you out of a whole load of trouble. Any questions about the local authority coordination and the roles and responsibilities? You will normally always have one person on shift that basically holds that badge of being the local authority coordinator. Okay, good stuff. Last but not least, we talk about training. Yes, site-specific training must be part of a new hire orientation. Mark, we did a whole load of safety training before people were basically allowed to walk the floors of the data center. To give you a rough idea, seat to street in Ironmark potentially was 2 months. It's not that anymore. It used to be 2 months before I got hold of the training material. Okay, so potentially it can take that long before people are allowed to walk the floors on their own. But you can see the training that's needed. Hazardous chemicals, physical health and safety risks, symptoms of overexposure, how to recognize the presence and release of hazardous chemicals, how to reduce and prevent exposures, procedures to follow. So you've got to have your documentation, you've got to read it, how to read labels and review the MSDS information. Location of the MSDS information is probably top of the list. Okay, and then the environmental monitoring, which is 24/7, 365. Okay, there's a little question at the bottom there. All employees at the data center are required to undergo annual refresher training. We know that is true. Okay, you're required to go under annual refresher training on this hazard stuff. Good, Deanne. Thank you very much. Okay. So for conclusion for today, thank you very much for some fantastic questions we've had through the live chat. Some fantastic integration there as well. So in conclusion, we've literally learned the type of hazards to expect, the chemicals we've spoken about, the electricity, the physical and the biological damage that can happen in these things. We've learned that labeling is really important. And indeed, we have our primary transportation devices and our secondary ones. There's basically another bucket we pour something into. And we know we need to have access to our safety data sheets, which is hazardous material. There should be one in every hazardous location with that specific hazard listed. And we know how to read one because we've basically gone through it together. We've talked about spill prevention, containment and response. So prevent it, contain it, and then respond correctly is the way we do things. And we know there's an emergency response plan with evacuations and notifications, and people have particular roles in terms of what they should and shouldn't be doing to help coordinate with local authorities, okay, and our EMS systems and fire police. Daniel Westmore is going to stick his finger into a fan. They haven't told you not to yet. They'll probably do some health and safety training. They might give you a special cap if you do that at work. That kind of brings us to the end of the session. Is there any questions that people would really like to ask? Special cap, exactly. Well, I've really enjoyed delivering today's session. Thank you very much for the integration you've actually had in there, and the feedback we've had in the live chat is essential. Really good. So I'm going to